calculate the pH of a solution that we have 1 mole, which is nice, it's going to be easy to calculate, of hydrogen cyanide, and it has...
That doesn't sound good. Hydrogen cyanide is probably extremely toxic.
Not probably, it is toxic.
It's a gas and cyanide together, so it can't be good. Let's be honest. Cyanide's bad on its own, but if you put it in a gas and it can float around where you can breathe it in, and that's bad. That's very bad.
All right, so what we're going to do is we're going to attempt to work out using, have you learned about Ka values and pKa values?
Don't think so.
No? Okay.
Maybe.
All right, let's do a recap then. I don't want to confuse you. We'll do that question next week then, because I don't want to.
Ka and pKa sounds familiar, but I don't remember.
All right. Cool. So I prepared just in case if you haven't heard of it, or we need to just completely do it. Okay. So as you can see, quick recap. We learned about POH today, and the pH plus pOH being 14. Yeah.
Yep.
Does that ring a bell today?
Yep.
All right. So this is where we're now heading into territories known as pKb and pKa. So if you haven't done this at school, I'm going to quickly explain. I'm going to explain it to you this week, and the next week we're going to do the applications of it. Ka is only to do with acids. So this is something you can write down. Ka is acids. Kb is bases. So it makes sense. A for acid, B for base. Yeah, you still with me?
So Ka for acids.
And Kb is base. So what we're trying to work out here is that, as you can see written in yellow right here, Ka is the equilibrium constant for the dissociation reaction.
Oh.
Yeah. So here's a bit of back text. So you know how some equations, or some reactions I may say, go to completion. Let's say what's an example would be? What would be an example? Acid plus base gives you salt and water. Yeah?
Yep.
So let's say HCl and NaOH goes to NaCl and water. That's a straight reaction. Do you agree? Because they're both strong acid and a strong base. Yeah?
Yep. To some not go to completion.
Correct. This is where we're coming into something harder. We're going to work out pH, not of just strong, because remember, we just did questions. We worked out the pH and pOH of strong acids and strong bases. Now we're going to be working out the pH and pOH of weak acids and weak bases. So, as you know, a weak acid would be things like nitric acid or carbonic acid, and they don't go to completion when they're in the reaction. Or let's say CH3COO. You know acetic acid, right?
Yeah.
Perfect. So it's going to have a Ka value, which means how much it has dissociated when combining with water. Remember, we just did the equation.
Okay.
Is it all kind of clipping together?
Yeah. So okay, so it's gonna be like, like the precipitation, like if you're finding KSP, but we're finding Ka, and you do it with finding your equation. You write your equation, and then you do the calculations below that.
Yeah. So pretty much you're correct. Like KSP, because we were working out. See, with KSP we were working out the precipitation or the solubility, right? And in this situation, we're going to be working at the pH or pOH value of a substance, and we're going to be seeing how much it's dissociated. So. Okay.
So similar to how much is dissolved.
Yeah. So here's an example. I'm going to quickly show an example. So can you see with HCl and water, it's a straight equation. It's not an equilibrium. It dissociates 100%.
Yeah.
Good. And as you can see here, a weak acid, you're going to go, let's say it's just an acid of HA, it's going to be breaking down to a cation and an anion. And the Ka constant tells you how much, like how far the equilibrium has gone. Does that make sense?
Yep.
Perfect. So this is where we're at. we're going to be working out the Ka values, and then we're going to work out the pH. Most of the time in high school, your teachers are nice enough. They're going to give you the Ka value, which you can then use to work out the pH, which we're going to try.
So you're gonna have Ka. You're gonna work out your Ka and then work your pH. So
yeah, but usually your teachers are nice and they give you the Ka value. So you only have to work out your pH, which I can just show you right. This is how you work out the Ka value, which you don't really need to know.
Do you need to know your concentration from your Ka?
Again, you'll be given that in a question. So here's an example right here. Can you see? Where you're asked to calculate the pH. This is a typical HEC question where you've got calculate the pH of a buffer.
Yep.
You've got a concentration right here. Can you see? 0.05 moles.
Yep.
Acetic acid, so H3COOH. And then we're told that you also have sodium acetate. And sodium acetate will give you the your product, which is CH3COO minus. Can you see?
Yep.
So this is the equation. As you could see that 14 equals pH plus POH. This is the same situation. It's easier because you've got the same equation used for every question, which is nice.
So you got your pH equals your pK plus log. Okay.
Yep. So you're going to do pH equals your pKa value, can you see? Which you've been given, which is nice because you don't have to work it out. And then you're just going to do negative log of 10, log comes in again, and you're going to do your product over your reactant. Remember pork? We did this with solubility as well.
Yeah.
So this is the same situation. You're going to do 0.07 over 0.05.
Yep.
How's that sitting in? How are you feeling about that?
So we're finding not knowing concentrations. You can use your concentration.
What do you mean you don't know? You do know your concentrations here.
Well, why would you do this then? So if you've got your concentration,
because you're working at the pH. You need to work at the pH. Remember?
But I thought you could get pH just with concentration the way we did before.
Yes, but you can. Remember when we talked about that's only to do with strong acids and strong bases.
Oh, right. So this is for weak ones.
Correct. That's what I said.
Oh, so that's why you need your pK in the equation.
Correct. Right. Perfect. Does that make more sense now?
Yeah, that makes sense
Cool. So because that's why I did those questions first. The first part, we worked out the pH for a strong acid and a strong base, right? Where it's easy because you just use the concentration, you get negative log, and you're done, right? But now we still need to work out pH. Like not every acid and base is strong. You have to agree with me. There's weak acids, there's weak bases, but we still need to work out the pH.
Mm-hmm.
Perfect. So that's how you do it.